An herbicide is found to contain only carbon, hydrogen, nitrogen, and chlorine. The complete combustion of a 100 milligram sample of the herbicide in excess oxygen produces 83.16 milliliters of carbon dioxide and 73.3 milliliters of water vapors at STP. A separate analysis shows that the sample also contains 16.44 milligrams of chlorine. A. Determine the percent composition of the substance. B. Calculate its empirical formula. A lot of information has been given in this problem. We know that a total of 100 milligrams of pesticide was combusted, and in turn 83.16 milliliters of carbon dioxide and 73.3 milliliters of H2O was produced. We also know that 16.44 milligrams of chlorine is produced. So the combustion took place under STP. This means that it's at 1 atmosphere pressure and 273 degrees Kelvin. So part A asks for the percent composition of the substance. In order to answer part A, we must find the milligrams of each element that were produced and divide that by 100 milligrams, which is the original total mass of the pesticide. To do this for hydrogen and carbon, we must utilize the ideal gas law, PV equals nRT, to find the number of moles that were produced and then convert that to grams and milligrams. A manipulation of the equation shows that N equals PV over RT, where R equals 0.0821 liter atmosphere per mole Kelvin. So let's start with carbon. We know that 83.16 milliliters of carbon dioxide was produced during the combustion. So since 1,000 milliliters equals 1 liter, this means that 83.16 milliliters equals 0.08316 liters, which is V, the volume. Now P, which stands for pressure, is 1 atmosphere since it's under STP. T, which stands for temperature, is 273 degrees Kelvin. And finally, R is 0.0821 liter atmosphere per mole Kelvin. By plugging this into the manipulated ideal gas law equation, we can then calculate the number of moles of carbon dioxide that were produced, which is 0.00371 moles. Since there's 1 mole of carbon in a mole of carbon dioxide, this means that there is 0.00371 moles of carbon. We can then convert the moles of carbon into grams of carbon, since there are 12.01 grams of carbon in 1 mole of carbon. So 0.04456 grams of carbon was formed. Since 1,000 milligrams equals 1 gram, 0.04456 grams then equals 44.56 milligrams. To find the percent composition of carbon, we divide this value by 100 milligrams because that's the total mass of the pesticide. So the percent composition of carbon is 44.56%. Since there are 4 sig figs in the question, we must make sure that the answer also has 4 sig figs, which we do. Now is hydrogen. We know that 73.3 milliliters of water was produced. This then equals 0.0733 liters of water, which is the volume. So the pressure is again at 1 atmosphere and the temperature is 273 degrees Kelvin. Plugging this into the ideal gas law, we find that 0.00327 moles of water was produced. Since there are 2 moles of hydrogen in 1 mole of water, this means that 0.00327 times 2 moles of hydrogen are present. We can then convert this into grams of hydrogen since there are 1.008 grams of hydrogen per mole of hydrogen. After calculating, we find that 0.006593 grams of hydrogen were produced. This equals 6.593 milligrams of hydrogen. To find the percent composition of hydrogen, we divide this by 100 milligrams. The percent is then 6.593%. Again, we must make sure there are 4 sig figs in the final answer. For chlorine, since we already know that 16.44 milligrams were produced, dividing this value by 100 milligrams gives us the percent composition. So as you can see, there's 16.44% of chlorine. To find the percent composition of nitrogen, we subtract the previously calculated values from 100%. So 100 subtracted by 44.56, subtracted by 6.593, subtracted by 16.44, and this gives us 32.407%. However, we must have only 4 sig figs, so the final answer is 32.41. And I have circled the answers to part A. For part B, in order to find the empirical formula of the pesticide, we must convert percent to mass, mass to mole, divide each mole value by the smallest mole value, and then multiply until a whole number is reached. For carbon, 44.56% would equate to 44.56 grams. Since 12.01 grams of carbon equals 1 mole of carbon, we can then convert 44.56 grams to moles of carbon. So the answer is 3.71 moles. We do the same for hydrogen. So 6.593% will equal 6.593 grams. Since 1.008 grams of hydrogen is in 1 mole of hydrogen, 6.593 grams equals 6.541 moles. Doing the same procedure for chlorine, we can see that it's 0.4638 moles. And for nitrogen, the value is 2.313 moles. The next step is to find the smallest mole value, which is that of chlorine. We then divide each calculated mole value by 0.4638 moles. For carbon, the value is around 8. For hydrogen, it's around 14. And for chlorine, it's 1, obviously. And for nitrogen, it's around 5. So since the values obtained are very close to whole numbers, we will not need to multiply until whole numbers are formed. Therefore, the empirical formula of the pesticide is C8H14N5Cl. And here are the final solutions to the question.